Hello everyone, welcome back to Math Top Grades or Math Top G as I like to call it. Today we will have vectors. I'll give you some basics of vectors, okay, and I'll give you also some common questions and common ideas which came before in the exams. The new thing today, in the description you will find a worksheet about vectors. You can take it, you can solve it, okay, and if you have any question about it, you can contact me on Telegram on this user. Thank you very much. Get your pen and paper ready, okay, and good luck. Hello everyone. Let's start with this simple thing here. If you have point A and point B, if you are talking about vectors, so you can write this as vector AB, okay, and make sure that you are writing the arrow like that, or it can be here an arrow like this, and we can call it, for example, P, okay, so we can call it also P. You can name it with this or that, so you can name it with AB or vector P. How can we write this in numbers? We can represent this as column vector. In the column vector here, you are writing two numbers. The upper one is horizontal change and the lower one is vertical change. From A to B, remember, you start counting always from A to B. So let's start with the horizontal change. So to move from A to B here, it's 1, 2, 3, 4, 5, 6. 6 steps to the right, that means you write here 6. And you go up 2 steps, so here this is 2. So you can simply say that vector AB equals 6 and 2. Okay, you can write it in that form. Sometimes it can be written as P only, vector P. So vector P or AB like this, it's the same exact thing. Remember that if you have another point here like C and you want to get vector AC, to get vector AC, you will move. What is the horizontal change here? To write it as a column vector, you will go here 1, 2, 3, 4. Okay, so 4 steps to the left, and remember, to the left means it should be negative 4. Then 1, 2, 3, 4, 5, 5 steps up. So this is the column vector which represents vector AC. Of course, there can be an arrow here, for example. Let's call it C or call it any letter. It will be given to you in the exam. Pay attention to this point, please, here. Here, as I told you, direction is very important in vectors. When we write here AB, that means from point A to point B in this direction, okay? What if we need to write here BA? BA is in the opposite direction, so every sign here is going to be switched. For example, here we have 6 and 2, so it's going to be negative 6 and negative 2. And it makes sense actually, because if you want to go from B to A, from this point here to that point here, you will have to go 6 steps to the left, then 2 steps down. Everything here is going to be switched. Okay, here vectors has two things, direction and magnitude. You have the word magnitude or the modulus, which means the distance between A and B. So the distance between A and B here, we can call it modulus, we can call it magnitude, no problem at all. How can we write it? Actually, magnitude or modulus, it's denoted by this. Okay, if I need to get the magnitude of AB, we write these two like the absolute value. And to get the value of that, we simply use it like finding the hypotenuse in Pythagoras. 6 squared plus 2 squared. Then, for example, here is going to be root 40. Okay, and you can get the decimal answer as you like, no problem at all. So, vector means two things. Direction, the direction is important, and also the modulus is very important here. You can get it, the length here, because you will be asked this question in the exam. It can be for many times. Let's take a look at this question together. Here I have three vectors, vector A, vector B, and vector C, as you can see here. Find 3A minus 2B. Okay, this is simple. All you have to do is multiply vector A by 3 and vector B by 2, then subtract them. When we multiply vector A by 3, it's going to be negative 9, and here is going to be 6, minus, multiply vector B by 2, it's going to be 10, and here 8. After that, all you have to do is just subtract them. So negative 9 minus 10 is going to be negative 19, and 6 minus 8 is going to be negative 2. Okay, this is simple. Find modulus of A. As I just mentioned, to find the modulus is the same as finding hypotenuse in Pythagoras. Here, square root. When you write here A, negative 3 and 2, take a look here, please pay attention. Negative 3 squared. Many students are writing it like that, which is completely wrong. Don't you ever do it this way. You have to put the negative 3 in brackets, then put power of 2 outside, because the squared will affect the negative also. Plus 2 squared, and in this case the answer is going to be square root of 13, which is 3 point something. You can find that in the calculator. Don't you ever forget to put, when you get a negative number, you want to make, for example, negative 5, you want to make negative 5 squared, don't forget the brackets, because here this is equal, for example, 25. If you don't write it with brackets, if you just write negative 5 squared, this is equal negative 25, which is completely two different answers, and it will affect your final answer badly. Okay, let's take a look at this question here also. The magnitude of the vector 20 and k is 29. He gave me the magnitude already, which is 29, and here he is asking us find the value of k. He needs us to find the value of this k. Okay, let's just apply the rule we know. I know that square root of 20 squared plus k squared equals 29. I need to get the value of k. In other words, I need to get k as a subject. Let's get rid of the square root by squaring both sides here. I will have here 220 squared, which is 400, plus k squared. This is equal 29 squared. This is 841. Okay, minus 400 from both sides. So k squared equals 441. You are so happy to get rid of the square of the power of 2. You will get square root here, and then you will write k equal 21. You will be proud of yourself and you leave your question like this, but you will lose 1 mark definitely. Why? Because here when you get square root, don't you ever forget to write positive or negative. Here he didn't mention if k positive or negative. He didn't mention that. So you have two possibilities, either k positive or negative, and you have to put it in your answer. You have to make it clear in your answer that k can be positive 21 or negative 21. In some questions, maybe you found it in the past papers before, find the positive value of k. In this case, you can just stick to the positive value. Don't write the negative value in this case. Now let's take a look at this question here. I have this question, as you can see. I have here a grid with x and y coordinates. Let's take a look at question A. Write down the coordinates of point P. So this is simple. Point P here, x coordinate is -1 and y coordinate is 4. So here it's -1 and 4. Okay. Pay attention to this one, please. PQ equals what? 3 and -2. Okay, what that means? That means to move from point P to point Q, you have to go 3 steps horizontally, and since it's positive, that means it's going to be to the right, and 2 steps vertically, which is going to be 2 steps down. Okay, where is our starting point? Our starting point here is P. So let's do that from P. 3 steps to the right, so that's 1, 2, 3. After that, 2 steps down, that's 1, 2. He's asking us to mark point Q on the grid, so this is point Q over here. Okay, so as you can see, point Q is this point here, which is 2 and 2. This is point Q. Okay, let's take a look at question C. Find QR, which means how can you go from Q to R? To go from Q to R, I'm going to move steps to the left, 1, 2, 3, 4, 5, 6. So 6 steps to the left, that means negative 6. And I'm going to move down also 1, 2, 3, 4, 5, 5 steps down, so negative 5. So here the column vector is negative 6 here and negative 5. Okay, let's complete the statement. PQ plus QR equal what? And here he gave us an arrow, which means he's asking us to write a vector. To go from P to Q and Q to R, simply this is equal to PR, because this is the result. At the end, you imagine that you're standing up at point P, okay? You went to Q, and then from Q to R. What that means? That what happened at the end? That means you moved eventually from P, and your end point is what? Is R. And this is the answer of question D. Now let's take a look at this question here about addition of vectors. Addition of vectors, for example, here, if I want to go from A to C, if you take a look at point A is here, point C is here, there is nothing here is written directly from A to C. That's why you have to take all the way around, okay, from A to C. And in this case, pay attention, please. Here, this vector, for example, let's call it P, and here let's call it Q. So in this case, it's going to be P plus Q. Why? Because we are in the same direction of P and the same direction of what? Of Q. Here, we went here, then there, so it's P plus Q. Let's take a look at the question next here, which is the same idea, but the only difference is you may go against in the opposite direction. Okay, how can I go from A to B? How can I find AB here? To find AB, so you need to go from A to B. This is simply the idea. Directly, you have nothing here from A to B. That's why you don't know what to do. You have to go around the shape. To go in this direction, you are in the same direction of C, so you are going to write C. To go in this direction here, this is in the opposite direction of B. Can you see this arrow? We are going against this arrow in the opposite direction. So we are not going to write plus B, no, we are going to write minus B. And then we are going here, opposite direction of A, so minus A, and this is the value, this is A, B as a vector. Okay, well, so the idea is simple. Let's go and find the next one immediately. Find BD. So BD, I am going here, then there. I'm moving from B to D. Okay, so it's going to be in the same direction of A and also the same direction of B. So positive B. Okay, CA. How can I find CA? CA, we are going to this direction, then here. The first one is the same direction as B, so we're going to write B. And here, this is the opposite direction of C. As you can see, the arrow is here. We are in the opposite direction, so this is negative C. All of these questions here are simple, and you may face it, no problem at all. Sometimes, and most likely, which is coming in the exam, becomes a lot if you have a point dividing a vector in certain ratio, and this is our next question, inshallah. Okay, now let's take a look at this question here. And the most important thing here is to try to analyze the question and write your data on the diagram. S is point on PQ, okay, we can see it here, such that PS to SQ is 4 to 5. So PS to SQ is 4 to 5. Most of you will write here 4 and will write here 5, okay, because they are just writing the ratio in the diagram, but I don't recommend that. I recommend that you say, how many parts in the whole PQ here? Here I have 4 parts and here I have 5 parts. So the whole PQ is 9 parts. Which means what? Which means here PS is 4 parts out of the 9. Okay? And SQ is 5 parts out of the 9. So this is the actual fraction which you are going to use it when you write the vector. Okay. Find OS. Let's go and find OS in terms of A and B. Okay, find OS, which means I need to go from O, from point O, which is here, till point S over there. Okay, you can go either ways. You can go this way, then PS, or you can go the other way, then QS, and there is a slight difference between them. I will solve it with both ways, inshallah. Now, OP. Okay, I need to get OS. OS equals, I will go from O to P, okay, as a vector, of course, we are talking about vectors here. Then I'm going plus PS. You know already that OP here equals A, and PS, you don't have it, but you know already that it is 4 over 9 of PQ. Of what? Of PQ. So PS equals 4 over 9, as we mentioned here, of PQ. Do you have PQ? No. So now let's find PQ, then go and substitute. PQ equals what? To go from P to Q, the direct way, it's not going to work with us. So we are going to turn around the shape. Here we are going to the opposite direction of A. So we will write negative A. And we are going with the same direction of B. That's why we are going to write here plus B. This is PQ. We will take this value here and substitute it over here. So A plus 4 over 9. PQ, we found it already, negative A plus B. Then let's do that here. A, let's distribute the 4 over 9 inside the brackets. Minus 4 over 9 A plus 4 over 9 B. Let's simplify it. A minus 4 over 9A, which means in your calculator, because some students are getting confused in that. Here there is 1 on your calculator, make 1 minus this fraction. 1 minus 4 over 9 is going to be 5 over 9. A plus 4 over 9 B. And this is the value of OS which is needed from us. As I told you, you can go the other way. You can go here, then there, and you will get till S only, I'm sorry, and then you will get the same answer. How can we do that? Let's do it together also. And let me erase this here. Okay. I need to go I need to go OQ, then QS. Okay. Then OS equals, okay, let me change the color also to make it different. OS equals OQ plus QS. OQ, you know already with what? With B. And QSM, please pay attention to the next part here. QS, you can see it's a fraction here. It's 5 over 9. But 5 over 9 of what? 5 over 9 of QP, not PQ. Again, you are going to this direction here. So it is 5 over 9 of this direction of what? Of QP. So 5 over 9 of QP. And now, the same way, you will have to find QP, then substitute it in this equation we have. How can we get QP? QP equals, you will go to this direction here, then to the other side. Okay, so you are going negative B plus A. You will substitute here with negative B plus A. So this is going to be B plus 5 over 9, negative B plus A. Okay, and then all you have to do here is just simplify it. B plus 5 over 9 multiply negative B, so it will be negative 5 over 9B. 5 over 9 multiply A, it will be plus 5 over 9A. Simplified here, 1 minus 5 over 9B is going to be 4 over 9B plus 5 over 9A, which is the same answer we got above here. Both of these are the same, but actually they are switched with a plus sign, so it's completely fine. Now, let's take a look at this question here. Remember, one of the most important things when it comes to vector questions like that, get your pencil and in the exam paper, write your data on the diagram itself. Okay, it will help you so much in the exam. Here, let's read this together. OPQR is a parallelogram. Okay, this word here, parallelogram, is very important because that means each two opposite sides are parallel, and the actually parallel means have the same vector. So for example here, if you can see that OP is here equals vector P, that means you can simply get your pencil and write here P. Here this vector is R, which means its opposite side here. Also you can write R, but we are not going to do that now because we have M. Till we know what is M, here he told me that M is the midpoint of PQ. Midpoint means these two parts here are equal to each other. So this is half R and this is also half of R. Okay, don't forget that, please. Now let's read the question here and solve it one by one. Find in terms of P and R, okay, in simplest form, OM. How can we get the value of OM? Simply to go from O to M, you'll go to this direction here, then here. This direction is the same direction as P, and this direction is the same direction as half of R. So simply you can just write P plus half R. Okay, this is the value of OM. Find the position vector of S. Let's read this together here. OM, okay, and RQ are extended. So you can see that RQ is here, is extended, okay? And let me highlight it here for you. RQ is extended, okay? And also OM is extended also here to meet at what? To meet at point S here, as you can see. طيب, what do we need to find here? We need to find the position vector of S. Put in your mind always, when it comes to parallelogram and you have this kind of extensions, you are looking for similarity. If you don't remember similarity here, so I will just remind you quickly. If you have a triangle like this, and you have one line here parallel to the third line, which means this line is parallel to that. That means the smaller triangle is similar to the bigger triangle. And the word similar means they have the same ratio. If you get the ratio between the sides, it must be the same. Let's apply this here. Over here, we have the bigger triangle here. Okay. The bigger triangle, and the smaller triangle we have it here is this SQM. Okay. This is the smaller triangle, and the bigger triangle is SRO. To get the ratio correctly, let's write the similarity statement. What is the similarity statement here? I will write that triangle SQM is similar to triangle. Okay, and let's write similarity like this. Similar to triangle, the biggest triangle, which is SRO. And be careful. Here you have to pay attention to the order of the letters. The order of the vertices is very important. Okay. Let's write our ratio here. SQ over SR. As you can see, I just took the first two letters from here with the first two letters from there. Okay. So SQ over SR equals QM over RO. Okay, let's do that. QM over RO. This is what we need here in this question. We don't need the third one because we don't have enough data. Here SQ, okay, and SR is the same as QM. What is QM here on the diagram? QM is here in this direction. So this is negative half R actually. Why negative half R? Because we are going to the opposite direction. So I'm going to write here negative half over. What is RO? RO here is in this direction, and it's negative R. Now the negative will be cancelled with the negative, and R will be cancelled with the R, which means SQ over SR equals, what do we have left here? We have only left with this half over here. Let's read it in other words. SQ is half of SR. Okay, SQ, which is this part, okay, is half of SR, and when you translate that into math, that means this point Q is actually in the midpoint. Is actually in the midpoint of SR. Midpoint means what? This part is P, so that means the other part also here is another P. Okay, and now we can solve our question easily. Why? Because here we got this with P already. Let's do that here. What is the position vector of S? In the position vector of S here, OS, position vector means starts from O. So OS means OP, okay, plus PQ plus QS. This is how can we go to from O to S. And OP is P plus PQ is R plus QS is P as we found it. And let's write it in simplest form. So the answer here is 2P plus R. R small, of course, not R capital. Okay? And this is how to deal with extension. When you deal with extension, remember you will use similarity. Yani most likely you will use similarity. And when you write the similarity statement here, you have to pay attention to the order of the letters. Okay? This is how can you deal with the extension. Okay, now let's take a look at this question here. O is the origin. This word here, origin, is very important because once it said find the position vector, you have to start from the origin all the time. Okay, OPQR is a parallelogram. Immediately I have to go to my diagram here and write the data I know. Here, this side, the upper one is parallelogram. Okay, so that means this part, this side here, this vector is A, and this vector here is B because they are parallel to each other. Okay. He told me that TRQ is a straight line with TR equals RQ. Okay, and here he said also that SO equals what? OP. SO, okay, and OP, they are equal to each other. Thank you. You can just write here B, okay, and here he told us also that this part equal to this part, so that means you can simply write here another B, okay. Writing these letters is very important on the diagram. You have to do that all the time. Pay attention to this, please. This is A. Okay, you can just write here A. STV, okay, is a straight line where ST to TV is 2 to 1. So ST to TV is what? Is 2 to 1. You have to understand that, and you have to translate that somehow into English. When I say the ratio between this to that is 2 to 1, that means this part here is double of this part. Okay, so the ratio 2 to 1 means one of the bigger one is double of the smaller one. Let's translate that into vectors. Since we agreed already, خلاص, this part here is 2 and this part here is 1 and it's double. This part is half of A. So here you can simply write that this vector is half of A. Okay, again, why did we write that? Because he told me that this ST is double of TV. Okay, which means TV, okay, here is half of ST, which means in other words it's just half of A. So simply you can write half A because definitely you are going to use it later in these questions. Okay. Now we wrote our data on the diagram. Let's just find the answer. Find position vector of T. Position vector start from the origin all the time, which means you have to find OT. Okay, where is OT? Starts from O. Let me change the color here to avoid any confusion. Starts from O, ends with T. You have two directions. You can go here, then here, or you can go to the other direction here, then there, and both will give you the same answer, by the way. Here, when we went to this direction, it is negative B, and then from here to there is what is positive A. Okay, you can write it here negative B plus A, or you can write A minus B. Both are the same. Okay, let's go to question double I here. Find RV. RV. I need to go from point R to point V. Okay, let's do that. So we are going this direction here, which is negative B, plus, now we are using this part here, which is half of A. Okay, so negative B plus half of A. Now, let's read question B here, and let's see how can we do that. Show that PT is parallel to RV. Remember, if you want to prove that one vector is parallel to the other, okay, you must prove that one of them is a multiple of the other. What do you mean by a multiple? Yani multiply 2, multiply 3. Okay, it can be multiplied, it can be half of it, it can be fraction of it. So anything, we have to get one vector out of the other vector. And let's find it together, let's find both together and see how can we do that. PT, okay, how can we find PT? Okay, PT is here. Okay, vector PT, I will go from P to T. This is going to be negative 2B plus A. Okay, this is the other, this is vector PT. Okay, where is the other vector here, which is RV? Vector RV, we found it here with negative B plus half A. So in this case, negative B plus half A. As I told you, you have to get one vector from the other. Here, this is the bigger vector, which I can convert it to this vector here. How can I do that? I'm going to take 2 as a common factor. Mister, why did you think about 2? Why will you take 2 as a common factor? Because here, I have to notice. What do I have to notice? I have to notice that this is negative 2b, and I wanted to reach negative b. What happened here? Mister, we divided by 2. Division, so we can take 2 as a common factor. Okay, so let's take 2 here as a common factor. I will have here negative b plus, Mister, how can we take 2 here as a common factor? You will have to divide by 2. So you have here 1, so it's going to be half a. As you can see, this vector here is the same as this vector. Remember, this vector here is RV. Okay? Do you know what that means? I can write that PT equals 2, okay, this 2. And instead of writing this, I'm going to write RV because they are actually the same. Since they are the same, so immediately you can just write then PT is parallel to the other one, which is RV. Then PT is parallel to RV. So again, what is the main idea of proving that 2 vectors are parallel? You have to prove that one of them is multiple of the other, like this. This number here, okay, not always 2. It can be 3, it can be 4, it can be negative number, it can be a fraction, it can be half, it can be 2/3, whatever. You have to notice, and you must have practice on that, how to convert one vector to the other by taking the common factor to prove that they are parallel. Now, let's take a look here. One of the most common questions which came a lot before in the exam, which is about the regular hexagon. Here in this regular hexagon, okay, of course, the first question here, what is the geometrical name of this polygon? This is a regular, okay, hexagon. Hexagon because it has 6 sides, okay? How did you know it's regular? Because he told me already here. Okay. There are some tricks, okay, about the regular hexagon I will tell you about in this question and the next question also. So you have to pay attention to that because it will save much time. Here he told me that O is the origin, okay. Origin means when he may ask about the position vector of any point, okay. OB is B, okay, you can see that here. OC is C, and also you can see that over here. Okay, let's continue. Find in terms of B and C in their simplest form, BC. BC, so how can I go from B to C? This is point B, this is point C. Of course, as I told you, we don't have a direct here. We need to find it. We will turn around the shape. And how can we do that? It will be the opposite direction of B, then the same direction of C. In other words, we can simply write negative B plus what? Plus C. Or C minus B. It doesn't make any difference. Okay. OA. One second, please. I recommend, okay, I highly recommend this. Once you find something here, it's better to write it on the diagram. For example, here we found BC, okay, go to your diagram and write what you got. What have we got here? Negative B plus C, okay. Why? Because it can help you. It will help you definitely later in some other question. Okay. OA. Where is OA? Okay, OA, O is here, A is here, okay. You're telling me, Mister, okay, I don't have the direct way as usual. Oh, that's why we need to find it here. what you will go this direction and here. Wait, you will say, wait, mister, we don't have this BA. What are we going to do here? Immediately, okay? Once you are dealing with a regular hexagon and they have this here, okay? Split it into two trapezoids or two trapeziums. Immediately, you have to go to its parallel sides, which means here and there, and write half of this vector. Okay, here in the same direction, this is half C, and this is also half C. Okay. Next, in the next question, you will know why. Okay, but immediately, even if you don't know it, right away, you come here, you find here C, you write in their parallel lines half C and half what? Half C. It will save much time for you. Now you can easily get the value of OA, which is B minus half of C. Okay. Position vector of E. Where is the position vector? Position vector means starts from O. Okay. And to start from OE, you need to find this. Of course, right now in your mind, maybe you are thinking, okay, mister, I will go here, then come back to E, but I have DC is missing. I can't find it. Simply, you have to know that what? Parallel lines, as I mentioned, they have the same vector. And if it's regular, so exact same vector, not just a fraction of it. OE here is parallel to BC. OE is parallel to what? To BC. So what are we going to do now? Simply, they are exact same thing, which is negative B plus what? Plus C. Why? Because they are parallel to each other over here. Mister, how can I know that they are parallel? You must know some properties of shapes, of geometrical shapes. Okay? So now, if you don't know, now I am telling you that this and this are parallel. Mister, wait, what do you mean? I mean here, this is equal to that because they are parallel actually and equal to each other. Okay? And here, OA is the same as DC because they are parallel to each other. We got OA here with B minus half C. Okay? So this is also, if you need to find the value of DC, it's going to be what? B minus half C. Okay? I hope it's understood over here. Now, let's take a look at another question. In this question here, we have a regular hexagon. He already told us that, so we don't have to prove anything or to write the name or anything here. And we have here CD equal P and CB equal Q. Okay, find CA in terms of this type. The second trick I'm going to teach you now is once you have a blank hexagon like that, it's better for you to do like this. You plot the center of the hexagon and connect these points here. When you do that, you are forming a parallelogram. And parallelogram is very good for us actually, because when this is equal Q, because they are parallel, and this is equal what? Remember, here you need to get CA. To get CA, so you have to get CB, then BA. BA is unknown, okay, and nothing connected to it to find it. What are we going to do is find a parallel line. We are going to find a parallel line to BA. I'm going to draw it here. This line is parallel to that. If I find this vector here, it's going to be the same exact vector there. And things will be easier for me. Okay. So now our first goal is to find this vector. Let's call this point O to make things easier for us. How can I get CO? So CO here equals P. Okay, I will go to this way, then this way. Okay, so this is going to be what? P plus Q. Okay, this is P plus Q. Which means what? Which means also BA here is P plus Q. Now what should we do? You can simply move from C to A. Yeah, CA equals what? Equals CB plus BA. And in this case, what will it be? It will be Q plus P plus Q. In other words, when you simplify, this can be 2Q plus P. Is it that simple? Yes, it is that simple. So when you see a question, okay, don't panic, just think and you will get the